Hey, I'm Luis, and when looking through some ideas, I found Python and Excel from the professor's ideas Word doc and Moodle, and I dug into it a little bit and found some resources online to kind of go help me learn more about it, which is good because I use Excel all the time at work. My major is engineering, so learning how to utilize Python and Excel can be helpful by creating what they're called shared moment diagrams of a beam. And we're going to go into that a little bit more. Share my screen. Share the Excel. So here we are, we're in Excel. And so there's a couple ways to get to Python. You could go to formulas and insert Python. You could do equals to py, create Python formulas. A neat trick I found was if you do Control Alt Shift and then P, it'll bring up the Python code. Um, that has been very helpful. So we can continue on with Dash Shift P, Control Shift P. So if you notice, the code bar is pretty small because it's usually just for Excel. You can either use this drop down menu to make it larger. You can grab here and kind of drag it down back up, or you could do a neat function I found was Control Shift U. It brings it down a little bit further, but we're just going to use this one here. So what I want to start with is by importing some libraries that will be helpful. So we're going to do import numpy, which numpy is a library that's for numerical computations in Python. And it's used especially for when you're working with like arrays or matrices. I'm just going to give it a different name as NP, a little bit easier to write when you're coding. Also going to import way to plot. So you can do matplotlib, matplotlib dot py plot. And it's kind of a module that it's great for so that Python's able to create visualizations and kind of has like a simple unit interface for creating the plots. I'm going to name this PLT just for simplicity. So what we are going to start with is defining some functions. So we're going to define. First one is obviously what we're here for, plotting beam diagrams. So if you have a beam, there's a load here. Imagine my arm's a beam and there's some load. So shear, as in it's gonna just shear off. There's also bending, where it bends within the beam. So what we want, like as engineers, is a visualization of what's happening as well as a quick computation. So that's what Python is here to help us do. So I'm going to do function, plot, define plots, beam, diagrams, give some parameters, length, W, or the magnitude of our load. And what I also learned was this triple string quote. It's called a doc string. And from this doc string, you provide like a description of the function's purpose, the parameters, and kind of what it does. And it's used for documentation. So what this is going to do is plot the shear. Let's make this a little larger. Of the shear force and bending moment diagrams for a simply supported beam with the parameters. We said the length, length of the beam, and we're going to give it a unit meters. Another job I'm working at is they have doing a bridge in Canada, so I'm using a lot of metrics. So W is magnitude of the uniformly distributed load. Give it a units kilonewton per meter. So uniformly distributed load is if you have, let's say, a beam again, and a couple points of the load distributed evenly, and it's like an equal load that's being applied as opposed to a point. So think of a whole bunch of those points evenly spaced. So we have that, and we're going to finish it off with the triple quote again. So we have that. And then from there, what we want is to continue on with some other functions that we're going to use to plot. So what we want is to define our shear force, X, which X is just going to be a position along the length of the beam. It's going to be important for later. I'm going to have this return the equation we want, which is W times the length, just in parentheses, the length, divide that by 2 minus X. Again, units is important, so we can have a comment here in the new one, just so when I'm looking at it later, I just remember, I guess. It's just a good reminder. Also, the bending moment. I'm going to define our bending moment along the position and have that returned also. But what do we do next? We want the plot, right? The actual image of what's happening. And so from here, we have to create some X values, right? X and Y coordinates. So what we are grabbing, we're going to use the numpy, NP, so line space. And so what we wanted from 0 to the length of the beam are spaced evenly, 100 evenly spaced points. We'll do the same for the shear force values. So here we will have shear force. Shear force, right? X for the force statement X and X values. Boom. Right. So it's going to calculate it at each position of the X values using the inner function X values. Okay. Do the same for the bending moment. Right? Because we define those shear force, bending force, make sure we have those in there correctly. All right, so now that we have that, we can continue on with plotting for the diagram. What we want to do is bring in now the plot PLT figures, figure, and this is going to be the size of the figure. 2, 12, and 6, which in this case is going to be 12 inches wide and 6 inches tall. Right. So ELT plot. What do we want as plot? X values, shear force values, and then we want to label it. We want to label it the shear force V or variable V that we were giving it earlier. So now quote and we're gonna give it two color. We just can go with like blue or something. Yeah, blue. Right. So instead of just a line, we want to have it filled between X values, here force values. This time the color is going to be a little bit different just so we can show the, I guess, the difference. We want to visually be able to see the difference. So we're going to use like a different, like sky blue. Ending it off. There we go. So what do we want now? We want the axes of what? So axis line 0, so 0, and then we want the color. We want that's where we want it at 0. It's position of it. We want it to be black. One. We should actually label this just if we want to change where the axis is at. Beam axis, right? So we want to give our plot a title. We type in title, call this again shear force diagram. Shear force diagram. Okay, close it out. Then we want to label our X and Y coordinates. So we get X label with the position along the beam. And label, oh, for the Y, label. So we want to call this the shear force units again. Okay, and then from there, true. Have a grid. We want to show a grid as well as the legend. So that is, we should actually label this shear force diagram, right? So it should be pretty similar for the bending moment. So instead of, we can just do here, copy paste it. Oh, here. So boom. Let's try that again. It's the one SF value. I had SF value instead of B moment value, BM value. But this is how it should come out. And this could be very useful for many applications. And yeah, so thank you guys. Bye. And boom, now we do have our two beams